Let's take a look at a problem together that covers concepts that can make up to 13% of the AP Calculus AB exam. Now, if you'd like to try the problem on your own first, go ahead and pause the video now and go ahead and do so. Otherwise, I encourage you to grab some paper, something to write with, and let's do some math together. If you'd like to try the problem on your own first, go ahead and pause the video now and go ahead and do so. Otherwise, let's go ahead and take a look at the problem together. Alright, so let f be a differentiable function. If h of x is equal to the quantity of this 1 plus f of 3x squared, which of the following gives a correct process for finding h prime of x, or the derivative of this function? Alright, so this right here is our original function, and if we're being asked to find the derivative of it, let's think about what strategies we know to find the derivative of functions. Now, as you think about all the different strategies you've learned to take derivatives, let's think about what makes the most sense as we look at this particular function together. So you can see here that we have this entire quantity raised to the second power, so we can think about the power rule. But inside the parentheses, you can see that we have this 1 plus f of 3x, so we have a function within a function. So whenever we have that composition of functions, we should be thinking of the chain rule. However, you can see inside here even, you see this f of 3x, which is another function within the function as well. So one way you can kind of think about this is that we have a function within a function within a function. We're going to go ahead and use the chain rule twice here. So applying the chain rule for the first time, if we take the derivative of this outside function, we're going to go ahead and take this 2 and use the power rule, bring it down in front, take away 1 from that power. We're going to have 2 multiplied by 1 plus f of 3x. So that's the derivative of the outside function raised to the first power. I'm not going to write it. Let's go ahead and multiply this by the derivative of the inside function. So I'm not going to go ahead and do that yet. I'm just going to write d dx of this 1 plus f of 3x. So this tells us the derivative of the outside function, and this tells us the derivative of that inside function. So here we use the chain rule for the first time. Let's go ahead and see how we're going to use the chain rule for the second time and why we need to. So this part of the derivative is all done, but what about this part over here to the right? Well, if we want to find the derivative of this entire function here, notice how it's another composition of functions. We kind of have this 1 plus f of 3x, so we can go ahead and find the derivative of that. But then notice how we have this 3x that's inside of this function, so it's another composition of functions. Alright, so keeping this first part the same, if we go ahead and find the derivative of 1, that's just going to be 1. And if we find the derivative of this f of 3x, let's see, that's going to be the derivative of f of 3x. The derivative of the outside function is going to be f prime of 3x. We can just write it just like that. But if we want to go ahead and find the derivative of the inside function, the derivative of 3x is just going to be the constant of 3. So here you can see we used the chain rule for the second time. This is where we used it for the first time, and this is where we used it the second time. So we found the derivative using the chain rule twice, and looking at our answer choices, D matches this perfectly. This would be our answer.